Hello friends, welcome to your channel Times of Coding. Today in our Scala Express series, we will discuss Scala operators and operations. In this session, you will understand how to perform operations while writing business logic. In previous session, we have seen Scala literals, types, numbers, characters, string and boolean. In this session, we will focus on operators, arithmetic operations, relational and logical operations, object equality, operator precedence and associativity. Operators are functions in Scala. Unlike Java, we will see how to utilize them. So here I am defining a variable called add 1 plus 2. So here plus is an operator, and now after executing, Scala will give us int is equal to 3, which is expected. Now this operator we can utilize as method also with dot sign. So when we write variable called addition is equal to in brackets 1 dot plus, this will be a method call to this statement. And Scala will give us int is equal to 3 as outcome, the similar way. In fact, this plus operator is having many overloaded functions. So here we were passing int value, we can pass long also. So we will use this function with int and long value now, which will give us the long value here after Scala execution. And this is how we write. This functionality of Scala is not limited to just plus operator. You can utilize any function like this. So now we will see one of the function from a string class, which is concat. So here we are defining one variable and we are passing two values, hello and Scala Express, and in similar fashion we are writing concat method. So Scala will give us the outcome from this statement as hello Scala Express as we define here. So in this example I have explained infix type of notation where our operator will sit between the values. Now Scala gives us two more type of notations, which is prefix and postfix. Is an example of prefix notation operator. So now we are writing minus 2.0 and Scala will understand minus 2.0. Not just like this, we can try similar logic with method call as well. In this method call we need to pass dot unary underscore minus. So in this way also Scala will understand that we need negative with this value. Scala gave us four operator as prefix operator, which is minus, plus, exclamation, which is for negation, and similarity operator. For postfix operator, we will utilize one of the method from string classes, which is two lowercase. So here we are defining one variable with value, and then we are utilizing two lowercase method in usual style, and then we are having postfix utilization here. In order to use this way, we need to import scala.language.postfix operation here. So once we execute this method, it will give us the similar outcome here. To gain more knowledge on Scala operators with the usage of its basic type, you can explore yourself by Scala API documentation. So let's move on arithmetic operation. I think just like another language, it has also the similar function, which is addition, subtraction, multiplication, division and mod. So these are the values we will get once we do this type of operations. While doing likewise operations, we can utilize unary operations as well, like this, which we have seen earlier with negative sign. Moving on to relational and logical operations, we have greater than, less than is equal to, greater than is equal to, greater than is equal to, and we have exclamation mark, which is not true. In this case, it will be not true. Once Scala execute, we will get likewise outcome. So 1 greater than 2 we will have false, 1 less than 2 we will have true. And then similar fashion, 3.5 float value greater than is equal to 3.6 float value. No, it is not, so it will be false. Small a is having higher value of SI than capital A, so it will be true here. In case of getting variable also, it is equal to not true, that means false. So moving on, we will talk about logical and logical OR operator. In order to use this logical operator, we need to write pipe symbol twice or AND symbol twice. Now we will see how to use them. So here I'm defining one variable called loves me is equal to true. And now when you create confusion variable, you will give loves me or not loves me. So here we will get true because here our value is true and here our value is false. In order to perform OR operation, if one value is true, it will give us the true. Moving on to clarity, here we are having loves me and not loves me. So here first we are having true and then we are having false. So in case of logical AND operator, first it will check this. If it is true, then it will go here and it will check. If it is false, then it will give us the false. So basically it will have one false hunt. It will do hunt for one false value. If the first value itself is false, it will not execute this statement. It will straight away give the false statement. Moving on to object equality, we will see how to use them. So for object equality check, we have two operators like is equal to and not is equal to. Here we will see how to utilize them. So 1 is equal to 2. Since it is not, so it will be false. Then 1 not is equal to 2, so it is true. Then 2 is equal to 2, that means it is true. In Scala, when it comes to object equality, Scala by default first make a null check whether the value which we are going to compare, it is null or not. If it is not null, then Scala will check the content of the variable, not the reference like Java. So it is not having any consideration for reference check. It is a pure content check. First it will check, let me repeat, first it will check the null references, if it is null or not. Then it will check what is the value inside and what are we comparing with. So here we are having one list which is having elements 3, 1, 2, 3 and then similar list. So here our values are same and it is not null, so it will be true. Moving on, list 1, 2, 3 and list 4, 5, 6. Here our content is different, so it will be for sure false. And see, after executing, Scala will give us false here like this. Moving on to next, 1 is equal to 1.0. Since the value is same, so it should give us true. Let's check. Yes, it is giving us true only. Then we are having list 1, 2, 3 is equal to hello. Since there is a difference in values, so it will be for sure false. And Scala is giving us the same. Since I told you earlier, in Scala first we check for null references, whether it is null or not. So Scala will have the null check. List is not null, is equal to null. So in this statement, we will not get any exception like in other languages. It is completely fine to write like this in Scala. But yes, content wise it is not equal, so we should get false here. And here also we can define null is equal to list. In similar fashion, Scala will execute this statement as well and it will give us false as we are getting here. Now I will show you one more example to be specific on the value side. When we do the equality check, Scala is actually do not focus on reference, it actually focus on the content, the value inside. So here we are defining welcome by concatenation and then we are defining welcome in one word. So when we do is equal to check for equality, it should give us true and here Scala is giving us true. Yeah. So this is how Scala does object equality check. Now moving on, we will focus on operator precedence. We'll actually decide which operation execute first. So moving on, we will see operator precedence. When you write some numerical expression or the mathematical equations, how Scala will execute and what precedence it will follow with operator. So let's say if you're writing 2 plus 3 multiplied by 4, Scala will execute the same in similar fashion. So by default, Scala first will do the multiplication. So 3 multiplied by 4, 12 plus 2, 14. So it should give us the 14 by default. But you can skip Scala default precedence by utilizing brackets in your expression. So first you will write brackets and then 2 plus 3 here, which will become 5, and then first this will get executed and our outcome will be 5 here, and then it will multiply by 4. So Scala should give us 20 now. So let's see what is the default operator precedence in Scala. So first preference, the higher precedence, it goes to multiplication, division and mod operations, and then it has second highest precedence to plus, minus and so on. The second last is all letters and then all assignment operators. All assignment operators are plus is equal to and multiply is equal to kind of operators. So let's say if you got some same precedence operator in one of the numerical expression, in that case your execution will start from left to right, and first your left operator will execute and then further on and then the right one and then the rightmost. So if you have got the same precedence type of operator written in your numerical expression, in that case your Scala will execute entire expression from left to right in order. I'm giving you here some rich functions that you can try at your home, and you can comment in this video once you execute this expression with the outcome of this expression what you get from your PC. If you don't get any output also, or if you made any minor mistake, for that mistakes also you can clarify to me in my comments of this video, and I will help you out to perform these exercises. So first I'm writing 4 max 5. What could be the output if you define like this on a Scala REPL or maybe worksheets in Scala through IntelliJ, which we have seen in earlier session. And then I'm writing 8 min 5. Then I'm writing minus 4.7 ABS. Then I'm writing 2.4 round. 1.4 is infinity. 1.0 division by 0 is infinity. 3 to 6 times of coding capitalized. Scala Express drop 6. So these are all functions I'm using here, which comes in the rich function category in Scala, which you can do the exercise in your laptop. I think we have covered everything in theory. Now it's time to do some exercise. So I'm opening IntelliJ. Now this is what the first window you will get once your IntelliJ open. And this is the singleton object and classes, which we have covered in our previous session. Now today we will create another package called Operators. In this operator, as yesterday's session, we will create another Scala worksheet. This Scala worksheet we will give the name as examples. Now here we have created successfully examples.scala worksheets. Now we will write the first statement. So here I'm defining one variable called add, and I'm doing 1 plus 2. So this is how we need to run, as I told you in previous session also. Since it is a first time, it will take some time. So let me fast forward it. Okay. Now it took a few seconds and our outcome is 3, which we were expecting. Now we have seen how plus operator works. Now it's time to see its method type. So here we're defining another variable called addition, and then I'm using same operator as method with dot. So now I'll run it, and our outcome is int is equal to 3, which we have expected. And after this we have talked about plus operator is just not the one function which takes as parameter this int and int value. It has many overload method versions. So we will see how it behaves with int and long. So here we are passing one int and one long information, and it behaves similar fashion. So that means it has overloaded versions. Now this functionality is not very limited to plus operator only. We have got few other functions also. Now we will see the string class function concat. So here I'm defining one variable const and then hello concat Scala Express. So here our outcome is hello Scala Express. That means we can utilize concat function method as operator as well. So far these are operators and functions we have used. It is in fixed type of notations. Now we will see some unary type, which is prefix type. That means it will come before the value. So let's start with minus. So I'm defining here minus 2.0. Now when I run this, Scala will give us this is the double type of value, and it has value minus 2.0. Not just like this, I can use unary method with this as well, which we have talked earlier. So here I will define dot unary underscore minus, and now we will see what Scala will give us. Scala is perfectly fine, and it is giving us the similar value. Basically what happens when we pass minus 2.0, our Scala interpret this statement as this one only, and by compiler it will precise into this statement. Now it's time to see another unary functions which comes under prefix category. So here I'm defining not true, and this will get us false value as we expected. Now after this we have talked about postfix operations. So in order to do postfix operation, first we need to import the scala.language.postfix. So here Scala successfully imported this postfix operations. Now we will define one variable which is greet variable welcome to TOC, and then we will use how postfix notation works. So here we are defining two lowercase method on greet variables. Greet variables was having value called welcome to TOC exclamation exclamation. So here everything get converted into small letters, and if you see here W was capital letter and TOC was capital letter earlier. This notation was a postfix type of notation. With this we can utilize our usual notation as well, which is greet dot two lowercase with method brackets. So now we will execute this and we will get the similar outcome. So it just depends to us whether we wanted to utilize the postfix type of notations or we would like to keep the usual way to note our method calls. Now moving further, we have discussed few arithmetic operations which I will write here, which is 2.2 plus 3.3. When we execute, it will get us the 5.5 as expected, just like any another language. Then I will do few more operations here. We will go to the output one after another. So here we are doing 6 minus 1, which should be 5. Since there is a difference of 2 characters, so it should be 2. 2l multiplied by 4l, that means 8. 13 divide by 3, that means 4. 9 mod by 4, that means 1. Now we will see how to utilize this operator by using unary operator. As we have seen earlier, the minus sign as prefix notation. So here we are defining one add variable and we are doing 1 plus in brackets we are defining minus 3. So let's see what it gives to us. The expected value would be minus 2 and here it is. We are getting the exactly same. There could be one question comes in your mind, can we use this minus sign with our variable name as well? And here we will see. Yeah. So when we do minus add, it will become plus add because the value was originally minus 2. So yes, it allows us to do in such way. Now after this we have seen relational operators, which we will do now. So first I'm writing 1 greater than 2 and yes, it is false as expected. Now I will write few more arithmetic expression where 1 less than 2, 1.0 less than is equal to 1.0, 3.5 f greater than is equal to 3.6 f, which should be false. Small a greater than is equal to caps A, which is actually true because it has higher ASCII value. And then we are defining one variable called getting, and here we are defining the value called not true, that means false, and here not getting, that means true. Now let's see what Scala compiler gives us. Yes, so it is giving us the exact same expected value, true here, false here. Small a is greater than caps A. Yeah, it is true in that. Then getting, not true, that means false, and not getting, that means true. Now after this, we have seen some logical operations as well, which we will do now. In order to understand the logical operation, we need to define one variable called loves me is equal to true. I'm defining here. Okay, it has successfully defined in Scala as well. So here we will define variable confusion, which is loves me or loves me not, and this should be true because true or false is true. And then we are having variable clarity, which is loves me and loves me not, so this will be false because true and false is equal to false. Now we will see what Scala gives us. It is having the same outcome as we expected. Now after this we have talked about object equality, so we will see now. So here I'm defining one expression which is 1 is equal to 2, and let's see, it is false as expected. And then I'm defining few more statements here, which is 1 not is equal to 2, expected is true, 2 is equal to 2, expected value is true again. Now we will run equality check on list type of values. So here these two lists are exact same. These two lists are having different number. Yeah, so the first one as expected true and the second one will be as expected false. Now if you remember, I told you Scala first it look for not null check when we do object equality check. So first Scala will see whether this value is not null, and then it will look for the content, not the variable reference. So content it will look, and since it is having the exact content, that's why it is true. Now we will have some more example to support our logic. So here I'm defining 1 as int type and then 1 as decimal type, you can see, and then I'm having one list with value 1 2 3 is equal to I'm comparing against hello string. Now if you see, it is as expected true because the value content is same, and here the value content was different, so false. Now since I was making a state that Scala makes first the not null check, so we will verify that logic as well. Here we have got nulls and hopefully it should not give us the exception. And yes, here Scala is doing the object equality check with nulls and it is not complaining with any exception. Now one more example I'll give you just to have a supportive to content checked in terms of object equality with welcome variable. So now we are having welcome, which is having a concatenation of will C and O is equal to welcome. So here it should give us the true because the content is same and it is not null and null value also. So here it is true as expected. After this we have discussed operator precedence, and for that I will give you two examples which will help you to distinguish them. Here in expression 1, I'm doing 2 plus 3 multiplied by 4 and Scala is treating the same way. First Scala, as per their default precedence, it will do the multiplication and then it will do the addition. So 4 multiplied by 3, 12 plus 2, 14 as expected. Here we can skip the Scala default precedence if we use brackets in our numerical expression. So first Scala need to execute this expression first. So 2 plus 3 is equal to 5 and then 5 will get multiplied by 4, so it will become 20 now, supportive for our logic. Now that's what the content which we have discussed today, and apart from this I have given you a few rich functions as well which you need to do exercise. If you are still watching this, we will see how to execute and what the results now in this video session only. So here I'm defining them all, and if you see here for max min, it should pick the maximum value out of these two, so it should give us the 5, which is 4 is always less than the 5, so it is giving us 5 as expected. Now we are picking up the minimum value among 8 and 5, so it should give us the 5 value, absolute of minus 4.7, so it should give us the positive 4.7 as expected, and since 4.7 by default double type will get considered in Scala. Now we are doing 2.4 round, so this round function will do the round off. Since this 0.4 is less than 0.5, it will get converted to 2 only. Now we will check 1.4 is infinity. So in order to get infinity, this must be false statement as expected here. Then we are having 2.0 divided by 0 and we are checking is infinity or not. This should be true because whatever number we will divide by 0, it will give us the infinity as answer. So that means true. 4 to 6, it is actually a range function which will have your 4, 5 and 6. So when we write in a Scala 2, that means it calculates all the number started from this number and added to this number. So it should have 4, 5 and 6. And here it is making range. Range is for to represent the value of 4 to 6. I'm utilizing 2.12 version of Scala. So if you are utilizing some another version, the most popular version of Scala is 2.11 and that's what most of the people use. So in that case your message could be little different. And now we are writing times of coding capitalize method, so it should technically capitalize the first letter of your string value. So here this T should get capitalized, and now we will see as expected, yes, it is getting capitalized here. The next function is drop 6. So this drop 6 will actually drop the starting 6 character from your variable value. So here we are defining Scala Express until this index, it will be 6 characters. So we should get only express out of it. So this is what Scala getting us. So in today's session, we have successfully completed operators. We learned how to use arithmetic operations. We understood what is the relational and logical operations. And we took a look on object equality. And we discussed operator precedence and its associativity. I hope you liked the content today. If you would like to receive my notification for my next video, you can subscribe the channel and you can press the bell icon. Plus, if you have any kind of feedback or suggestion to me, because today we are completing the 10th video on this series called Scala Express, and this series is going to be the part of Times of Coding channel. So any kind of feedback or any suggestion you have, please pass on to me through the comments on the video. Thank you so much for watching this channel. Have a good day.